Hi, today we're looking at Functional Skills Maths Level 1. We've got the Training Qualifications UK exam board. This is examination paper 2 and we're going to start with the non-calculator section. Question 1. Work out 40 squared. Well, 40 squared, or anything squared, means itself multiplied by itself. Now we could write this using the column method, but because we've got zeros here, we can ignore the zeros for now and say, well, 4 times 4, well, that's 4, 8, 12, 16. And because we've got a 0 here, add 1 on the end, we've got another 0, another 1 on the end. So we get an answer of 1,600. Question 2. Work out 4,560, that's a comma there, divided by 100. So we're dividing, so we're going to be making the number smaller. We've got 2 zeros, so that means we need to move the decimal point. When actually at the moment we can't see a decimal point, so it must be at the end of the number. We're going to move it twice, once for each 0. So move it once, move it twice to in there. So we end up with 45.60, but we don't need the 0 after the decimal point, so we can just put 45.6. Question 3. Work out 0.18 plus 0.3. This I'm going to do as a column, so 0.18 plus 0.3, and you'll see I'm lining up the decimal point. So that means my units are lined up, which is 0 in both cases. Then my tenths, we've got 1 and a 3. We've got nothing down here, so I'm just going to put a 0 in. And that means I've now got something to add to. So we've got 8 plus 0 is 8. 1 plus 3 is 4. 0 plus 0 is 0. So we get an answer of 0.48. Question 4. Work out, I'm going to put my commas in so I can read these numbers more easily. And remember, if you're putting the commas in, start from the end if you haven't got any decimal points or decimal places, and count 1, 2, 3, comma. So from the end of this number, 1, 2, 3, comma. So we've got 87,540 minus 69,180. So I'm going to write this as a column and write the 69,810 beneath it. It's going to be a minus. So we've got 0 minus 0 is 0. 4 minus 1 is 3. 5 minus 8, well, 5 is smaller than 8, so we can't take 8 away from 5. So instead what we're going to do is take 1 from the 7, so we'll reduce the 7 to 6, and put a 1 here, so we've now got 15. So 15 minus 8 is 7. We can bring the comma down, keep it in line. 6 minus 9, well again 9 is bigger than 6, so we can't take it away from 6. So we're going to reduce this number by 1. Each time you're always going to just reduce it by 1 so that you can give the 1 over here. So we've now got 16 minus 9, which is 7, and 7 minus 6, which is 1. So we get an answer of 17,730. Question 5. Convert 50 pence into pounds. So 50 pence or 50p. If we're turning it into pounds, we're going to think, oh, there's 100 pence in a pound. So that means we need to divide it by 100. So the decimal point is moving once, twice. Now, that's a long explanation, but you're probably just going to know, well, if it's 50 pence, I've got 0 pounds and 50p. Question 6. 2 centimetres, cm, represents 2,400 metres on a map. So every time you see 2 centimetres, it actually means 2,400 metres in real life. What distance does 3 centimetres represent? Okay, well, what I'm going to do is I'm going to say, well, 2 centimetres is 2,000, or represents 2,400 metres. I'm going to work out what 1 centimetre is, because 1 is half of 2. So if I want to know what 1 centimetre would be, I'm going to need to divide 2,400 by 2. So I get half of it. So in other words, 2,400 divided by 2. 2 goes into 2 once. 2 goes into 4. 2, 4. That's twice. 2 goes into 0, 0 times. 2 goes into 0, 0 times. So we're saying that 1 centimetre represents 1,200 metres on the map. Because we've halved both of them. Now, the reason I've done that is because if we want to know what 3 centimetres is, well, 3, well, that's just 3 lots of 1. So all we need to do is multiply our metres by 3. So 1,200 times 3. 3 zeros, still 0. 3 zeros again, still 0. 3 times 2, well, we've got 2, 4, 6. 3 times 1, or 1 times 3, is 3. So we get an answer of 3,600 metres. Question 7. Round both 12.38 and 8.5 to the nearest whole number. Use your rounded values to estimate the answer to 12.38 times 8.5. Show your working. So what they definitely don't want you to do is to multiply these numbers exactly. They want you to estimate, and they want you to do that by rounding the numbers. Okay, so let's start with the 12.38. We want it to the nearest whole number. Okay, well, these are the whole numbers, the 12. So we have to look at the digit that comes next, which is the 3. If it's 5 or more, we'd round up. If it's less than 5, well, then we just get rid of it. So rounded to the nearest whole number, it's going to be 12. Let's do the same with the next number, 8.5. So this is the whole number. So we look at the first digit that comes after the decimal point. 5. So we said 5 or more we round up. So that means we increase this value by 1. So we get 9. So instead of 12.38 times 8.5, we want 12 times 9. Now you might know this from your times table knowledge. Great if you can go straight to the answer. If you're not sure, we can say, well, 9 times 2 or 2 times 9. So 9, 18. Let's put the 8 through the 1. And 9 times 1 or 1 times 9 is 9. Add 1 is 10. So we get an answer of 108. Okay. Question 8. Jamie is planning a trip to a theme park. Jamie wants to go on the day with the least chance of rain. The probability that it will rain on Monday is 3/8. The probability that it will rain on Tuesday is 4/10. On which day should Jamie go to the theme park? So you've got 2 ways of doing it. Well, at least 2 ways. One way is to work out a common denominator. So you can compare the fractions while they have the same denominator. What I like to do with these is to turn them into decimals. So 3/8 or 3/8 is the same as 3 divided by 8. And if we were doing that with the bus stop method, we'd put the 3 inside the bus stop and 8 on the outside. Now you might look at it and say, well, how can you do that? Well, 8 doesn't go into 3, or it goes in 0 times. So we put a 0, we've got to carry the 8. So that we've got somewhere to put the 8, we need to make this 3.0. We can then put the 8 in front there because we haven't used it. So then we say, well, sorry, not the 8, it's the 3 that's carrying over. Oh, silly me. So now we're saying 8 doesn't go into 3. What about 8 into 30? Well, you've got 8, 16, 24. So that's 3 times. Decimal point. And that was 24. So 25, 26, 27, 28, 29, 30. So remainder 6. So we're going to need another 0 to put our 6. Now we say, well, how many times does 8 go into 60? 8, 16, 24, 32, 40, 48, 56. So that's 7 times 56. And then 57, 58, 59, 60. So that's 4 left over. So we need another 0 and put our remainder in front of it. And we keep going until we don't get any remainder. Let's see what we get this time. So we need 8 into 40, or 40 divided by 8. So we've got 8, 16, 24, 32, 40. That's exactly 5 times. So 3/8 is equal to 0.375. We can do something similar with the 4/10. So, well, with this one, I could divide it that way, but I'm going to say, well, actually, this one's a little bit simpler for me because I know that 1/10 would be 0.1. So 4/10 is going to be 0.4. If you remember, these are our units or our ones. These are our tenths. 4/10. So now we're just comparing one with the other. We want the day with the least chance of rain, so we want the smaller number. Well, 0.375 is less than 0.4, so we want to go on Monday. Okay. Question 9. Hayden's drama company is putting on a play. A plan view of the stage is shown. So the plan view means we're looking straight down onto the stage. So 13.5 metres across, 5 metres deep. Each person requires a minimum of 2.5 metres squared of floor space. How many people can be on the stage at the same time? So first of all, we want to know, well, how much space have we got in total? So we want the area, and the area is equal to the length times the width, which in this case is 13.5 times 5. Now I'm going to do this as a column. I'm going to ignore the decimal point for now and just do 135 times 5. 5 times 5, got 5, 10, 15, 20, 25. 5 carry the 2. 3 times 5, 5, 10, 15. Add the 2, 16, 17. 1 times 5 is 5, plus 1 is 6. 675. But remember, we had a decimal place. So 1 decimal place there means 1 decimal place in the answer. So we've got 67.5. That's going to be metres squared. Right. We know that each person requires a minimum of 2.5 metres squared of floor space. How many can be on at the same time? So what we want really is 67.5 divided by 2.5. Okay, now with this one, there's a few ways we can do it. We can, what should we do? We can think, well, this would be the same. If we move the decimal point 1 to the right on both of them, we end up with 675 divided by 25. If we do that using a bus stop method, it looks something like this. Okay. So we're going to say, well, does 25 go into 6? No, but what about 25 into 67? Well, with this, especially if you're thinking in terms of quarters and 25% and things, you should be able to work out that 2 lots of 25 would be 50. And we can quickly check this. 2 5s are 10, 2 2s are 4, and 1 is 5. So we know that 2 25s are 50, so 25 goes into 67 twice. Well, if it's 50, if we've got 67, 67 minus the 50, 7 minus 0 is 7, 6 minus 5 is 1. So we're going to have 17 left over. So we end up with 25 into 175. Now again, that might look a little bit messy, but you can think 175 divided by 25, that's also the same as 175 over 25. We could then start to simplify it down, but I'd hope that you'd be able to see, well, I've got 25, I've got 75. These are numbers that are sort of familiar. So maybe we can see, what about if we work with our 25 times table? So we've got 25, would be 1. 2 25s will be 50. Another 25 will be 75. Another 25 will be 100. And then we're going round again, so 125 would be 5. 150 would be 6 25s. And 175 would be 7 25s. So we're going to end up with 27 there. Okay. It might seem a bit strange doing it with 25 times table, but as I say, if you're converting from fractions to decimals and you're doing things like a quarter equals 0.25 and a half is equal to 0.5 and 3/4 is 0.75, which is 75%. These are all of the sorts of things that you should be practicing, and then you can kind of spot that there's some patterns going on. If not, and you wanted to do it a different way, just trying to think of how we could approach it differently. Where we had this, we know that we wanted 67.5 divided by 2.5. We could have actually, to get rid of the decimals, we could double both of the numbers. And if you do that, you end up with saying, well, doubling it takes you back. You'd end up with 135 divided by 5. So it's like an equivalent fraction. You've doubled the numbers to get rid of the decimal, and now you've just got a straight division. And if we did this, 135 divided by 5, so this is like our alternative, this is or, I'll sort of fence this off, would be saying, well, 5 doesn't go into 1, 5 into 13 goes twice, remainder 3, and 5 into 35, 5, 10, 15, 20, 25, 30, 35 is 7 times. So you still get an answer of 27. So I'd be interested to know if you found a more straightforward way of doing it. Unfortunately, at the moment, these are the best ways that I can think of. So now we're onto the calculator section. Okay. Section B. Question 1. Measure the size of angle A. Right, so if we're going to measure it, we need one of these, which is a protractor. So I find the crosshairs of my protractor here, and I'm going to put them on the corner of the angle that I'm interested in. And I need the angle to be inside the protractor, and I want one line to be lined up with the bottom line of my protractor. Make sure I've got that right there, line that up like so. And then we're going to, because we're starting from 0, so we're going to be using the numbers on the inside. We don't want to start from 180, start from 0, because this is our angle and it's getting bigger. That would be 10 degrees, 20 degrees, 30 degrees, 40 degrees, which is where it meets. So 40 degrees there. And I've just written the answer in here. These are 40 degrees. Now what you'll see is, we put that back on. If we counted from the other side, it would take us to 140. And you can see that 40 plus 140 is 180 degrees because that's the number of angles in a straight line. Okay, so it's just a good way to check which of the numbers should I be using. You can also say, well, this is less than a right angle, so I know my answer is going to be smaller than 90. So straight away I can see 140 is going to be too big. Okay, question 2. Let's move this up a little bit. And they're saying, which drawing shows the correct net of a cylinder? Right, well, a cylinder, think of like a can of Coke or a can of beans. It's going to be something like that. But the net of it means if we sort of cut through it and flattened it out. Now, if we did that with a cylinder, you'd have a circle at the top. You've actually got a circle at the bottom. So you'd have a circle, another circle, and this bit in the middle would fold out. Oh, not drawn it very well at all, but it's just a sketch as a rectangle, which looks just like B. In fact, I can write my B in the answer box. Okay. Question 3. Write this fraction, 3/5, as a decimal for part A and then as a percentage. Well, remember, we can use our calculator. So if we want it as a decimal, all we need to do is remind ourselves that 3/5 means 3 divided by 5. Which is, as a decimal, 0.6. And if we want it as a percentage, we just multiply it by 100 to give us 60%. In fact, because it's a percentage, I will put the percent sign as well. Question 4. Riley is cooking food. The instructions for preparing the food say, cook the food for 150 minutes. Leave to stand for 1/4 of an hour. How long will it take to prepare the food in total? Give the units in your answer. Right, so we've got 1 in minutes and 1 in 1/4 of an hour. Well, I know that 1/4 of an hour is 15 minutes. If you weren't sure about that, hopefully you'd know that there's 60 minutes in an hour. If you don't know that, then I'm afraid you're a bit stuck. But if you did know 60 minutes in an hour, divide it by 4 for 1/4, and you get 15. So in total, it's going to be 150 minutes plus 15 minutes, which is 165 minutes, which we can write in here. Now note it says, give the units in your answer. It hasn't said you have to write it in hours and minutes, so I'll just leave it like that. If you want to convert it to hours and minutes, that's fine, and you won't be marked down, but you'll just be using up time that you could be doing something else. Okay, question 5. Calculate the range of these numbers. Well, the range means the difference between the biggest number and the smallest number. And the way we work out that difference is we subtract the smallest number from the biggest. Well, the biggest is 18. And the smallest, because we've got negative numbers, it's going to be the most negative. So like the biggest negative, which is the -5. So remember, we said you want the biggest minus the smallest. Well, the biggest is 18 minus, and the smallest is -5. Now, it's really helpful to write it out like this in 2 steps, because you'll see we've got 2 minuses here. It's not 18 minus 5, it's 18 minus -5. When we got the two minuses together, that becomes a plus. So we've got 18 plus 5, which gives us 23. And if you want to see that, you can use a number line to say, well, I've got 18 up here, minus 5 down here. So this difference is going to be 18, and this down here is 5. So we need the 5 and the 18 added together. Question 6. Cameron is visiting a friend who lives 70 miles away. Cameron plans to leave home at 10:15 a.m. The average driving speed along the road is 35 miles per hour. Cameron uses this rule to work out how long it will take to get to their friend's house. Okay, so we've got the distance in miles. We then divide it by the average driving speed, and that equals the time taken in hours. Cameron tells their friend they will arrive by 12 p.m. Has Cameron worked out the correct time? So let's try it. We start with the distance, which is 70 miles. Divide by the average speed. They've told us the average speed is 35. So we want 70 divided by 35. And that equals the time taken, which is 2. Okay. So if they're leaving home at 10:15 a.m. and it's taking 2 hours, so we're adding on 2 hours. Well, 5 plus 0 is 5, 1 plus 0 is 1, 0 plus 2 is 2, 1 plus nothing is 1. So it's going to be 12:15, and because it's gone past the 12, it's going to be 12:15 p.m. Well, 12:15 is after or greater than 12 p.m. So has he worked out the correct time? No. Question 7. Nikki pays £2,050 into a new savings account. The savings account pays 5% interest per year. How much money will be in the savings account at the end of the first year? Right, so £2,050. 2,050. So no hundreds, just 50. We need 5% of that. So we want 5 out of 100 times 2,050. Okay. This is my 5%. And that gives me 102.5, or as money, that would be £102.50. That's the interest they've earned. They want to know how much money will be in the savings account. So it's going to be that plus the £2,050 that they started with. So if we add on 2,050, we get up to 2,152.5. Again, that's going to be 50p. Put this one on. Question 8. 600 students are studying science at a college. This is 1/15 of the total number of students that attend the college. How many students attend the college in total? Okay, so you've got 600 represents 1/15. Well, if you want all of them, you want 15/15ths, so we're going to need 600 times 15. So 600 times 15 gives us 9,000. I think that's a very nice 3-mark question, that one. Okay. Question 9. Charlie is taking part in a run. The route of the run is shown below. So we start, run 620 metres, then change direction, run another 970 metres, change direction again, and run another 750 metres. Charlie thinks that the total distance is more than 2.5 kilometres. Is Charlie correct? Well, we got metres, we got kilometres, so we're going to want to convert one to the other. I always think it's nice to get rid of the decimal point. So if we convert this one, so we should know that 1,000 metres are 1 kilometre. So if we want to convert this into metres, we're going to need to do 2.5 times 1,000. Which is 2,500 metres. Okay, now all we need to do is work out how long's the actual route. So it's going to be 620 plus 970 plus 750. So these all added together gives us 2,340 metres. Well, 2,340 is less than 2,500. So is Charlie correct? No, he's not. Question 10. Alex has this cake recipe. The cake recipe serves 10 people. Flour, 0.3 kilograms. Sugar, 0.2 kilograms. Eggs, we need 4. And butter, 0.25 kilograms. How many kilograms of flour does Alex need to make a cake for 12 people? We're only interested in flour, so we can kind of ignore all of this stuff. Now, this is how much it needs for 10 people. 0.3 kilograms. If we think for one person, well, it's going to be 0.3 divided by 10. Oh, sorry, 0.3 divided by 10, which gives us 0.03 kilograms. We actually want it for how many people? For 12 people. So we just need to multiply it by 12, which gives us 0.36 kilograms. Now, it's always good to check how they want their answer. In fact, they said they want it in kilograms, which is fine. So we can just write 0.36 kilograms. If they wanted it in grams, for example, then we would want to multiply it by 1,000, because there's 1,000 grams in a kilogram to give us 360 grams, but they haven't, so we just keep it like this. Question 11. Harper needs to put a fence around this garden. So we've got our diagram here with a lot of measurements, not all of the measurements, but we've got a lot of measurements written on it. Harper thinks the total length of fence required will be less than 50 metres. Is Harper correct? So they want a fence to go all the way around, so this is the perimeter we're looking at. So we need to add up all of the sides, but we haven't got them all yet. Well, we kind of have. This side's missing, but this side is going to be the same as this one. So we've got another 3.5. This side's missing, but it's going to be the same as this one. So we've got another 5.2, should say metres. And for the bottom, well, the bottom, we know 15 metres is all the way across the top, but we've already got 4.6 here and another 4.6 here. So if we add the two 4.6s together and then take them off, so in other words, let's do that one step at a time. So 15 minus two lots of 4.6 is 9.2. 15 minus 9.2 means that gap is 5.8 metres. Okay, so if we want to work out the whole perimeter, we need to add all these numbers together. I would find it helpful to mark on a diagram where you're going to start counting, so you don't go too fast. We'll start here. So we're going to have 15 metres across the top. Then we come down 3.5 metres. Then we go along 4.6 metres. Then come down 5.2. Then we go along 5.8. Then we go up another 5.2. Along another 4.6. And finally we go up 3.5. So we get that the perimeter is equal to 47.4 metres, and that is less than 50 metres. So is Harper correct? Yes, they are. Okay, question 12. Kai has paid these amounts into a savings account in the last 6 months. So in January he paid £50, February £30, March £40, April £190, May £170 and June £150. Kai wants to pay the same amount into the account monthly. Kai decides to save the mean amount paid into the account in the last 6 months and an additional 10% each month. How much should Kai pay into the savings account each month? So firstly we want to work out the mean. And that's the total divided by how many we've got, or the frequency. So the total is going to be our 50 plus 30 plus 40 plus 190 plus 170 plus 150, which gives us 630. And how many? 1, 2, 3, 4, 5, 6. So 630 divided by 6 is £105. And we can do a quick check because that looks reasonable, because we'd expect it to be more than the smallest number but less than the biggest number. So it looks like it's roughly in the middle. But we do need to add an additional 10% as well. Okay, so we've got to think, well, how are we going to work out what 10% is? Well, we want 10 out of 100 times £105. Still got 105 in there, so we multiply that by 10 divided by 100, which gives us 10.5 or £10.50. So let's add these together. £10.50 plus £105 gives us 115.5. Because it's money, we need to make that £115.50. Question 13. Jude sells candles online. The table shows how many candles Jude has sold over the last 4 months. So they sold 20 in January, 64 in February, 42 in March, and 98 in April. Use this information to create a bar chart. Okay, so we've got 4 categories there. Now I'm going to do a vertical bar chart. That means my bars are going to be going up. And I'm going to start drawing on the bar chart. You can start on the corner so your labels are underneath. I like to do it all on here. It's personal preference. We need 4 bars across the bottom. So if I did 1, 2, 3, 4, it'd be very small. You want to use at least half of the paper. So let's say, well, that could be 1, 2, 3, 4. And we want the bars to be the same width, which those are. So what label am I going to have? Well, these are my months. And we're going to have Jan, Feb, Mar, and April. Right, now we need to put our values on the other side. So our biggest number was 98, so we want to go at least as high as that. We're probably going to be going up to 100 because we're going to be rounding our numbers here. So let's look at what we've got. Well, we've got these boxes. What about if each one's worth 10? We'd have 10, 20, 30, 40, 50, 60, 70, 80, 90. That would be 100 up here. So I'll write those back in, now that we know that that's going to fit, because 100 is more than 98. We want to be at least as high as the largest value. Now, when you write these in, we're going to make sure we put the labels on. So this is going to be number of candles. Then we need to start drawing our bars. So in January, we've got 20 candles. So 20's here. So draw that straight down. You don't have to have your bars touching. I make mine touch just because I find it quicker and easier that way. For February, we've got 64. So this is February. This would be 20, 30, 40, 50, 60. Now, if we go 1, 2, 3, 4, you can see we're nearly up to 70. And the reason is because each of these boxes isn't worth 1. If you look, we've got 1, 2, 3, 4, 5 boxes, but we've got a difference of 10 from 60 to 70. So 10 divided by 5, you can use a calculator, but that's 2. So that means that each of these is worth 2. So we wanted 64, so we'd have 60, 62, 64. So we're going to go across to here for February. And then we can draw our bars or our lines down. Okay, now for March, what have we got? We've got 42 candles. So again, 40, and each of these boxes is worth 2, so 42 is just going to be one little box up there. And for April, this is where we need to, the big one, we've got to go all the way up to 98. Okay, so we've got 80, we've got 90, 92, 94, 96, 98. It's going to be up here. Get the ruler again. And then draw the sides down. I always like to have a title as well, so we can just call it Candle Sales, something like that. Okay. So now we can go on to question 14. A caterer needs to prepare 240 sandwiches for an event. They need to be made on brown bread and white bread in the ratio of 1 to 5. So that means every one sandwich made on brown bread, we're going to have 5 made on white bread. We're then told that 5% of the brown bread sandwiches need to be vegetarian. 30% of the white bread sandwiches need to be vegetarian. Use this information to complete the table. Right, so a lot of words here. We've got to turn all these words into a few numbers. Okay, and the way we can start is by saying, well, they need to prepare 240 sandwiches. So that's going to be the total way over here. Okay. Right, let's start with one bit of information at a time. They need to be made on brown bread and white bread in the ratio 1 to 5. So let's do a quick ratio table here. So brown, white, and I'm going to have a total column. So every time we have 1 brown, we have 5 white. If that's all we had, well, the total would be 6. But actually, we haven't got 6, we've got 240 sandwiches in total. So we've got to think, how are we getting from one row to the other? And the way we do that is by doing the opposite operation and going backwards. So 240 divided by 6, we need to multiply by 40. So the number on brown bread is going to be 1 times 40, which will just be 40. And on white bread, it's going to be 5 times 40, which is 200. And we can check that 200 plus 40 takes us back to 240. Okay, so that's helped a little bit. So that means we can say total number of brown bread is 40 and total on white bread is 200. What we're trying to do now is the split. And we're told that 5% of the brown bread sandwiches, so that's 5% of these, need to be vegetarian. So 5%, so 5 out of 100 of the 40 sandwiches. So 5 divided by 100 times 40, that gives us just 2 vegetarian sandwiches on brown bread. So the rest must be non-vegetarian. So in other words, this would be the 40 minus those 2. So 40 minus 2 gives us 38. Right, now let's look at the white bread ones. 30% of the white bread sandwiches need to be vegetarian. So 30 out of 100 of the white bread ones, which is 200. So we've got 30 divided by 100 times 200. And that gives us 60 vegetarian sandwiches on white bread. So the non-vegetarian are going to be the 200 minus the 60 vegetarian ones, which gives us 140 non-vegetarian ones. Now we just need the totals. Well, I've already got the 140 here, so if I add on the 38, I get 178 non-vegetarian in total. And vegetarian, I've got 60 plus 2, well, I know that's going to be 62. And on to the last question, question 15. Quinn has a fish tank in the shape of a cube. Well, actually, let's think of that, a cube. A cube is a square, which has a square top and a square side. So something like that. The tank has a side length equal to 60 centimetres. So the side is 60 centimetres. But if it's a cube, well, that means the height is also going to be 60 centimetres and the width is also 60 centimetres. Quinn needs to fill the tank with water until it is 7/8 full. How many litres of water does Quinn need to pour into the tank? Use 1 litre equals 1,000 centimetres cubed. So the first thing we want is the volume. And the volume of a cuboid, because a cube is a special type of cuboid. If it was a cuboid, it would be the length times the width times the height. Now for this example, it still is. It just happens because it's a cube, it means that all of these measurements are the same. So 60 times 60 times 60, or 60 cubed, you could call it. So 216,000 centimetres cubed. Right, now we only want 7/8 of this. So we want 7 divided by 8 times 216,000. So times 7 divided by 8, we get 189,000 centimetres cubed. But they want to know how many litres of water. And we're told that 1 litre is 1,000 centimetres cubed, so we want to divide it by 1,000. And if we do that, we get 189 litres, which we can put in our answer box down here. And that's the end of the paper. So I hope you found it helpful. Please like the video, subscribe to the channel, turn your notifications on so you find out when I add more videos, and I look forward to seeing you again soon. Thank you.